Welcome friend. Today we will discuss analysis of statically determinate beams. This is the first chapter. Now there are two important aspects of structural design. The first one is safety, which means structure should be able to withstand all the external loads without any considerable damage. Right. So this considerable damage should not be occurred in the structure when we applied the external force. That relates to the safety of the structure. At the same time, we also look out for the serviceability. Second aspect, serviceability, which refers to the condition other than the strength, right? So we are not talking about the strength of the body. We only see about the serviceability under which the structure is still considerable useful. The preliminary object of this course is to study how to determine the parameters which constitute the basis of structural design, both for safety and serviceability. So further in our next semester, sixth semester, we are going to design the structure. In the same, we think about the safety and the serviceability that include the limit state of collapse and limit state of serviceability. So same thing will be carried forward in the design of structure in sixth semester. So let me begin with the course. So first of all, we must know the degree of freedom, right? So what do you mean by the degree of freedom? The degree of freedom of a mechanical system is number of independent coordinates required to completely specify the configuration of the system. Motion of the object is three-dimensional space can be completely described by three displacement along their coordinate axis and three rotation, right? So see, we have three axes. This is the x-axis, y and z. So see here, if we apply the moment in the x direction, then we will get some rotation, that is theta x. If we provide the moment in with respect to the y, that is in the z xz plane, so in that we are getting, suppose, the rotation, that is theta y, and same way theta z. So see here, our body has a 6 degree of freedom, right? One, that is slope, that is theta, and same that is the deflection, that is delta, right? So it means body has the 6 degree of freedom, right? So therefore in the three-dimensional space an object has 6 degree of freedom. Similarly, two-dimensional plane, an object has 3 degree of freedom, right? So if we have the two-dimensional thing, then we have only 3 degree of freedom, that is in the x, y, and third, that is the rotation, right? So it means we have only 3 degree of rotation when we talk about the two-dimensional body. Now let me when we are talking about the strength of material, that means we must know about the force. What do you mean by the force? So let me take the one object which is subjected to 4 forces, that is P1, P2 and P3. This is the center of gravity, and we also applied the moment, that is M, right? So this rigid body is subjected to 3 forces, that is P1, P2 and P3, and the moment, that is M1. So if we just if you want to show the same body, then it means we must know the resultant of P1, P2 and P3. Suppose that is the R force, right? That is acting on the CG. At the same time, we have the moment, that is the M, right? So the force is an element which can have the capability to produce the motion, to decrease the motion, or to increase the motion of the body, right? That is known as the force. So we are not going into detail because already you have you know the detail of the force in the engineering mechanics. At that time you also studied the different force system, right? In that co-current force, coplanar force, non-concurrent force, non-coplanar force, like that, parallel force, like parallel force, unlike parallel force, couples, and all that thing that we already discussed in the engineering mechanics. So see, to solve the typical structural problem, we use the equation involving the force and other component. Force may consist of either a linear force that tends to produce the translation, or a couple that tends to produce the rotation of the body on which it acts. The system of the planar force acting on a rigid structure can always be reduced to two resultant force, right? A linear force R passing through, see that we have already discussed over here, that the R is passing through the center of gravity of the body, right? When you apply the force, the resultant force of that force is directly acting on the CG, right? At the same time, moment M about the center of gravity, the moment M is evaluated by the summing of the moment. So in short, when we want to solve the force system and on the rigid body, we always do the algebraic sum of the resultant force and resultant moment. Now let me see some supports and support reaction, right? So here in the table it shows different type of the support, right? So one is the pin support, then roller support, fixed support, and internal hinge. Right now when we talk about the pin support, right, suppose this is the pin support. So like this, if you just rest the one body on the pin, then what happen, right? So when we just put it like this, then your support try to resist the horizontal force as well as the vertical force, right? So here it shows that when we have the pin joint, so the pin joint is subjected to the two type of reaction. One is the horizontal support and horizontal reaction, and another is the vertical reaction. Same way the roller support. So roller support consists only a vertical translation. It means it resists only the vertical force, right? Only the vertical force. Then fixed support, it's denote like this. You can show this is a symbol of the fixed support, and which kind of constraint it has, right? So when we just hold one pen in, suppose this pen, if we hold it like this is the fixed support, right? So when we apply the force, it resists the vertical force, as well as when we provide the horizontal force as external force, it resists the horizontal force, and when we apply the moment, it also resists the moment. So here you can see that fixed support has three kind of the reaction. One is the vertical reaction, another horizontal reaction, and the moment, right? And the internal hinge. So internal hinge is a related displacement of the member. So it has two kind of the reaction. One is the horizontal reaction, and another is the vertical reaction. Now when we see when we have the any beam, suppose this is the beam, right? AB is the beam, A support is a pin support, and B is a roller support, and it is subjected to P force at the C point, right? If we want to draw the internal reactions, right? Suppose we want to draw the internal reaction over here. So see, A is a pin support, so it is subjected to two reaction. One is the vertical reaction, that is AY, and another is the horizontal reaction, that is AX. At the same time, B is a roller support, so it is only subjected to vertical reaction, that is BY, right? So suppose we take the cross section over here, that is MN, right? So if we take the cross section MN, so this is the MN section. So this MN section is subjected to three internal reaction. One is the Vx, right, that is a vertical internal resistance, Fx, that is a horizontal internal resistance, and the moment, that is Mx, that is the moment of resistance of the section. So this is the free body diagram of AB beam. Now equation of static equilibrium, and object at rest is said to be a static equilibrium if the net force. So it means suppose we have any if we have any body, right? Suppose we take one body, which is simple support, and we apply the force, that is suppose P. So this body remains static if it satisfies the equilibrium condition. It means the summation of force that is equal to 0 and summation of moment that is equal to 0. So here we do the algebraic summation of force. It means suppose that this is RA and this one is suppose RB. So algebraic summation of force that is RA plus RB minus P is equal to 0. If it satisfies this condition, then and then only it becomes a static body, right? So if you right, so algebraic summation of force is 0 and algebraic sum of moment is 0. If your body satisfying this condition, then we can say that your body is in static equilibrium. Now determinate and indeterminate structure, right? So as in the previous we see that we have sigma f is equal to sigma m is equal to 0. So basically it is sigma h is equal to 0. It means summation of horizontal force is equal to 0. Sigma v, that is summation of vertical force is 0, and sigma m, it means summation of moment is equal to 0. So it means we have the three equilibrium condition. Summation, algebraic summation of horizontal force is 0, algebraic sum of vertical force is 0, and algebraic sum of moment is 0. So if you have a beam, right, suppose you have any structure is said to be a determinant if the equation of static equilibrium alone are sufficient to permit the complete analysis of the structure. So it means that using these three condition, if you are able to solve the structure, then we can say your structure is determinate. If you are not able to solve the condition, solve the beam, then we can say it is indeterminate structure, right? So it means your equilibrium condition is not sufficient to determine the reaction in the beam or in the structure, then we can say this as a indeterminate structure. So here that is all about the first chapter.